Hello, everyone. Good afternoon. My name is Zach Sweigart, and I'm here to talk to you a little bit about how we do modularization at Plaid. For those of you who don't know who Plaid is, we are a company that allows you to connect your app and your users to their financial institution. So we provide an SDK that you can throw into your Android app, whatever you're building, for financial services, and allow you to connect those users to their bank accounts to get things like their transactions, their balance, to authorize them, and several other use cases. So what we're going to be talking about today is, first of all, what is modularization, why you should do it. Once you start doing it, how do you organize all your modules? A little bit about how we decided on our app architectures that'll fit into that modular organization. Talk about navigation, some build tools and Gradle tips and tricks, and then finally a little bit on our SDK and how we release it. So to start off, what is modularization? But before we get there, take a thought back to your very first program. It was probably something like this if you're like me and you started on Java, and everything's right here in one file, in one class, and it's nice and simple. Oops. So we got one file. From there, we probably made things a little more complicated, and we moved on to multiple files. Things got a little bit more complicated, and now we started throwing things in different packages, and things keep getting more complicated. So where do we really go from there? And so now we're looking at modules. And so modules are collections of your source files, your build settings, your Android manifest, if you're using an Android module. It allows you to divide your project into these discrete units of functionality. And now that we're moving to Kotlin, we've got internal as opposed to package private, so it allows you to do better encapsulation as well. Your app could be single module, but we've planned and thought of using many modules for a lot of the benefits we'll go over later today. Again, each one of these modules can be independently built and tested and debugged all through the Gradle tool line. So creating a new module is simple. You open up Android Studio. Even when you're building a new project, it'll first start off and you can select an Android application. If you want to add a module, you'll see this screen, and then there's a whole variety of different types of modules you can pick from. Oops. So once we start creating all these modules, we've got a whole bunch of questions like, what is the responsibility of each module? How do we organize them? We don't want something like this. We have to avoid, circular dependencies at the very least, but at the same time, we want to be able to reuse them in the most logical way possible. And how do we improve our build time? So that's one thing that everybody talks about by adding modules, and how you organize your modules will greatly affect how it implements your build times. So why should we do this? Number one, like I said, we'll reduce our build time because we'll be able to cache work. So if there's a module that doesn't change, Gradle can hold on to it and just reuse that build artifact. This will allow us to parallelize work, including running unit tests. We can reduce code. So if there's a module that is a core functionality that's used across different projects, different features, you can just reuse that directly. We can also create pure Java modules. So Android modules are pretty slow to build because you have to compile the resources and build the dex file. Java's way faster, so if you've got functionality that does not require the Android framework, skip it. Again, increase code reuse. So once we've got these features or use cases that we want to use across different apps and features, we can put those into one place and reuse them. Again, we want these to be loosely coupled from each other so that they fit into any project that we're using, but we want them to be highly cohesive so that each module has one role and we can just plug that in. It helps us simplify our development and increase our team size. So there's clear lines of ownership. Teams can own one module, one feature, without stepping on toes of other people. It'll reduce concurrent modifications, which is awesome when you get more than like 3 or 4 developers. You're not going to deal with merge conflicts every day. And it'll allow you to structure your code similar to your organization. So if you start to get to a larger organization, you're like, we've got a core team, we've got a feature A team, feature B team. This will allow you to be like, okay, you work in your area and I'll work in mine. And as long as our contracts are well-defined, we don't have to worry about what your changes are. And finally, it'll help us enable dynamic delivery for dynamic delivered features and instant apps. So for instant apps, you have to have less than 4 megabytes in your module that you're delivering. If your entire app is a single module, most likely your app is bigger than 4 megabytes. But by shaving off a little piece of that into its own module, or even with a few sub-modules, you'll enable instant apps for your application. Similarly, for on-demand dynamic delivered features, if you've got features that aren't super common or may not be used by the user, you can reduce your download size, which will increase the conversion rate in the Google Play Store, just by pulling out those features into modules that'll be delivered when the user wants them. So now we've got modules, and we want to figure out how can we organize them in some kind of logical manner. We want to think about layers. So the great thing about layers is it really supports modifiability and reuse. And this diagram shows you we've got lots of layers in the way we've structured our app. They're arranged in each layer. For us, we allow you to access anything that is below your layer. We allow skipping. And this is mostly so that we don't have to use like a API, which can kind of leak dependencies into your interface. We want to be very explicit about which modules are being included in your module. So when you build, you're only building what you know you want to build. And so we can dive down and look at what each one of these layers in our SDK actually does and what their responsibility is. At the very top, we've got the application layer. This is a single module for your app, or for us, we're developing an AAR, so for your APK file or your AAR file. It has your application class or an application scoped object, as we have. It sets up your application scope dependencies. If you're using Dagger, this is where all your singleton classes will be. And it creates implementations of the base interfaces. The big idea for this is it's a module you want to keep really small, because this one, whenever you're building your app, has to get built every time. So the less that you have to redo, the better. Next layer down is the feature layer. This is really where all of our UI lives. So each activity is in a separate module. We use the rib architecture, which we'll get into a little bit later, but there could be some subtrees. These aren't necessarily single feature modules on the level, but the idea is that the features live at this level. Some examples, you've got your login screen, your home screen, your settings, and then all of their subscreens would be in there as well. Next layer down is the application library layer. So this is our business logic that is specific to our app or our AAR file. This is usually reusable between features, but not necessarily reusable between products, although it could be. Some examples are like your user profile, your app-specific storage, like your database for this app in particular, and all your DAO files, your feature flag module, which may be slightly different between different applications. At the bottom is the base. This is another module that usually we want to keep pretty small because it is generally reused in like all the feature modules and the application module. It contains your constants, your resources, model objects, interfaces. And these interfaces allow us to communicate between modules on the same level. So in terms of dependencies, two modules on different levels can communicate. One can implement one below it, but you can't talk to ones on the same level. And so another thing is we try to limit changes here pretty often, because if somebody makes a change here, then you have to rebuild this module, and then everybody else who's working on different features has to rebuild it as well. Below that is the core library layer, and this is wrappers around the Android framework. So if you don't like the default shared preferences and you want to add a reactive layer, this is where you'd kind of put that. Our networking layer, we do some wrappers around that add convenience functions for adding Stetho and RX. And then there's also like storage, and our ribs library is here. These are the ones that are really generic and can be shared across all sorts of products and all sorts of applications that you're building. And at the very bottom is the utility layer, and these have absolutely no dependencies outside of the Android framework. They don't depend on any other modules, and they're super generic. It's where we keep pure functions, our RX transformers, generic resources like styles that we use across all of our product lines, and extension functions all live down here. So I mentioned at the feature module, there could be like some sub-levels, and so how do we handle that? If we look at this screen, we could break this down. This is from the Link SDK. Currently, it is a web view, but if we built it natively, how would we break this down? We could think that like the top bar is like the header bar, then we've got like a search bar, and we've got a grid of institutions. And so each one of those could be a sub-module if we really want to break down this functionality and allow people to work on it in parallel really easily. So similarly to how we do the layers for the whole application, we do layers inside features. So you'd have a base feature module, which would have shared resources and interfaces that would be used across these different sub-modules. And all these modules, again, are at the feature level, so they can depend on everything below it, like the application libraries, the base library, the core libraries. And the pattern just follows from there. So app architecture. I mentioned we use ribs. We looked at a bunch of different app architectures, MVVM, MVP, Viper, ribs. And we really wanted an architecture that supports decoupling and that supports this hierarchical layered flow like we have for our module organization. And ribs was like a very natural follow on from there. So ribs, the smallest building block, this is our base business logic. You've got a builder, an interactor, a router, an interactor, and a builder, hence rib. an optional presenter and view for the ones that have UI. And so this kind of it encapsulates your functionality, and when you put them together, it kind of forms a tree that mimics your view structure. So a rib can have no children, it can have one child or many children, just like a module can have a child, one child, no children, no dependencies. And children can be added conditionally, so we use a plugin architecture to allow you to conditionally add or not add child ribs. To communicate downward, we use RX and pass data on streams, and then to communicate upward, we have listeners. So this is how that interface gets injected in there. Basically, the base would have an interface that's implemented at the top level, and then you can call it from the child ones as you inject the actual object into it. And then ribs on the same level have to communicate through their parent, because again, like modules, we don't allow you to talk directly on the same level. So this also works really well with Dagger. We're not currently using the Uber's open source ribs library. We've built our own, which is pretty similar, but it's also heavily dependent on Dagger. So at the same way that we have these layered ribs and layered modules, we've got a Dagger tree, which is also layered. So you've got your singleton app scoped objects. Each feature has an activity scope. And these activity scoped objects are put onto a dependency fragment that's like a retained fragment. And if you dive deep into view models, essentially it's a retained fragment with a convenience method on top. So we're doing the exact same here, but with Dagger. So then when you re-inject these objects, they're the same object you had before, and state is maintained, and you can restore your app from there. And then below that, each rib has its own scope. So as long as the rib is active, you're going to be injecting the same object and maintaining your state there. So as this is data, and the objects live only as long as necessary, but they can outlive the app lifecycle. So it solves that rotation problem really easily, and you can kind of forget about it. So at the app module, looking at Dagger, we've got our app scope and our app module, and we provide things that live at the app scopes. And the app scope is a singleton scope that we define for the root module. Below that, we've got the activity module, which looks really, really similar, except we have this parent component dependency. And this is an interface that is implemented by our app scope component. So what this says is, for our activity, if we need this application scoped object, go and grab it from my parent, which is the application scoped object. And then we provide our activity level object down there in the module. And so then when we go another level lower to a rib, it's the exact same pattern. So we've got an interface that says, that should not say rib object, it should say activity object, and it provides its own rib object. So you're always grabbing from the layer above to get something that should already be created. Okay, so now we've got our architecture, we've got our modules, but there's a huge problem with this. As I mentioned, we've got activities in separate modules, and those modules cannot talk to each other. So they don't know about each other. We really want to write an intent like this that says, I'm giving you my activity, I want to go to the home activity, and I want to pass a parameter of some value, and then I want to start that activity. But I don't know about home activity, so that causes a problem. This won't compile. But we really want a clean, type-safe interface for navigating. One option that we have is we can use explicit intents. We can say, go to this class directly. We don't really need to know about the class. But the big question is, where do these live, and how do we refactor them? If I change home activity to main activity, this string doesn't get updated, which is a real pain in the butt. You got to go through and find all the different changes. So what we did is we created an interface in our base module. And because it's in the base module, all the feature modules can implement it and get access to it. That is our navigator interface. It just has a method like go to home, which takes in an activity that's going to be starting this intent, and the value string for our property that we're passing along. And because this is in the base module, we will implement the navigator interface in the activity, or in the application module, in the activity or application scope, sorry. And that knows about all the features. So because it knows about all the features, we can then grab the home activity directly, and it's type safe and it's cast, and then when we refactor, it will refactor just fine. And so here you see then our go to home just says the activity, sets the parameter, and then calls start activity. Super simple. And this pattern of defining an interface in the base module and then implementing it at the top and then passing it down to the feature module is one we use pretty extensively within the feature subgraphs and within the application as a whole. Moving on to build tools and Gradle. So a lot of the benefits you want to get from modularization happen in your build tools and Gradle. So some of the essentials you got to have here if you're going to be building multi-module projects, you want to turn on parallel, you want to turn on configure on demand, you want caching because when you build an object, you want to make sure it stays built. And then you want to also use incremental for APT. As of or pre-1350 of Kotlin, it wasn't incremental. If you're using the latest version of Kotlin, that's now standard, so you'll get incremental builds there, which is fine. Adding a new module can be really a pain in the butt to set up your Gradle file every time, especially if you start getting to tons of modules. If you were at Square's talk, they've got, 1,400. Writing this 1,400 times is a pain. So you can add this in your root build.gradle file for your subprojects. It basically says, if this is an Android module, set the build tools, set the default configs. You'll notice we're using the Kotlin dependencies there. So we get auto completion and the types for the build tool and all those variables like config.buildTools. Another one is for unit tests. So if we want to run our unit tests in parallel, this is an easy way to do it. It basically says, look at how many processors I have and use half of them so we don't kill my machine entirely. And then run all those tests in parallel, which will speed that up quite a bit. So as we start adding all these modules, you'll start to notice your IntelliJ or Android Studio, whatever you're using, gets really, really messy. And you've got this long list of modules, and you don't know which ones are for what or why they're there. And you really don't know which ones are shared, which ones belong to one product or another. So you can just nest them really simply. You've got some that go in the app, you've got some that are in the core, some that are shared. And then in your settings.gradle, you just have to prefix whichever subfolder they're in. And then once you want to include those dependencies, you use the same path. So if it's in the core and it's core lib2, you got your colons to basically replace the slashes for your path. Again, we only use implementation to be very explicit, which is a little verbose, and that comes at the cost of writing maybe a few extra lines of code, but it makes it very explicit for what our module depends on, and we don't leak any interfaces. And why leaking interfaces is kind of not a good thing is if we have this situation where we're using API versus implementation. So on the left side, you'll notice that we've got API on the base module for this app module. So if we make a change in the base module and we want to recompile, say there's an app module at the top, and we want to recompile that, it has to recompile everything because we're exposing, or we want to recompile one of the feature modules. We have to recompile everything because we're exposing the interface of the base module via this app lib module. Instead, if we use implementation directly, then we can make a change there, and the feature modules are basically cached because they haven't changed. Now, you could say, maybe this feature module has an implementation out of the base module. We're in the same situation, but in that case, we've made the choice to have that dependency, and we're very aware of it then, as opposed to just having this accidental leak. So looking at, for us, most of this applies to both AARs and APKs, applications and libraries. But there are some nuances with a library that we ran into that we were not expecting. We were in the unique situation of we just built our SDK from the ground up about 4 months ago, so this is all very new. And as I mentioned, it's an AAR, and we decided to go straight to multi-module, get all these benefits. We see the architecture, it's really smooth. But there's a major problem. The Android Gradle protocol does not support multi-module builds for AARs. So if all of you could do me a huge favor and go to that link and star that bug. The bug has been open on Google for 4 years, and they have not decided that it is a high priority. But because of that, we have to use FATAAR, which is a library by Qizong. We want to say a big thank you to him, because otherwise we would have to build this plugin ourselves, which is not really my strong suit. So basically, it's real simple. You apply the plugin, and then you switch your implementation to embed. The one weird thing about this, and it's, I think, just a nuance of the plugin itself, is it doesn't keep track of subdependencies. So our top level module has to have embed for every single submodule. So when we add a new submodule to a feature, we have to add it again to the top level module. And this is something I think Google could help us out with official support. So let's flag that as a bug for them. So that's it. Are there any questions?